Welcome back, everybody. In lesson 510, we're going to do the investigate part of the traversal block of lessons. And what we started looking at in 5.9 is the idea of a traversal, where we essentially take the work we've done with lists. Okay, lists are good. And the work we did with loops, loops are good as well. Combine them together and use the loops to traverse through the list and kind of do something with every stop along the way. Okay, objective today, identify common programming patterns using traversal. Okay, basically we'll do some vocab real quick, and we'll dive into some example programs and look at how traversal is used. All right, so first off, let's define it for you, formal definition. We'll just say traversal is the process of accessing each item in a list one at a time. So for example, let's say I have a list of friends here. And let's say I want to go through that list and print off every friend that I have. Now there's all kinds of other things I could do here. I could search the list. We could find the biggest value. We could add all the stuff in the list together. We could find the average. Okay, a whole bunch of different things we could do using the same traversal idea. Okay, the way I'll do that is typically I'll use a for loop. Okay, for loops are basically set up, they're optimized to traverse over lists. We'll have our counter variable starting at 0, I gets 0. Okay, and we typically call it I because we're referring to the indexes of a list. And we'll start at 0 because remember lists are 0 indexed. We're going to go while I is less than my friends list.length. Okay, so the length is 1 greater than the last index. Okay, but as long as we're less than that, we'll keep on hitting spots in our list. And then this I++ just means count up by 1 every time. And what are we doing here? Well, I'm just going to console log the friends list at index I. So if I clicked run on this program, what would happen is we'd print off Ross, and then I would go up from 0 to 1. We'd print off Joey. I'd go up again. We'd print off Monica, Rachel, Phoebe, Chandler, all on down the list. So let's jump over into code.org now and see some traversal in action. Okay, so I'm on lesson 10, and we're starting off on Bubble 2, the first kind of example app here. Like usual, you're going to want to follow along here, kind of code along with me. We'll make some modifications to these programs as we explore them. We'll kind of point things out as we go. So if possible, pull code.org up along with this video here. And let's see what we've got in this first app. Looks like we have a mile tracker where I can input some mile times, and I'll just keep it simple. Let's say that I just ran a 6-minute mile. And let's say I got faster the next time, ran a 5-minute mile, a little faster the next time, ran a 4-minute mile, and then I was tired the next day, so I ran a 7-minute mile. So what this is doing is similar to some apps we've seen. It's keeping track of all my different mile data here. We've done apps like that. But this new one, notice what it's doing is it's calculating the average for me. It's finding the total number of miles. It's finding my fastest and also my slowest mile. Okay, let's take a look at how that is all working. Okay, so when I run my app, I begin by having an empty miles list. Okay, it looks like each time that I add something here, walk that mile, it's going to add to that mile list. Okay, and that's just happening with my new mile time button here. It takes the time here, makes a new mile time, and it appends it to my list, and then adds 1 to the total miles. Okay, then we also have some variables to hold the average, the fastest, the slowest, the total miles, and a new time. Okay, and then after I click that button, the update screen function is called. And let's take a look at what this update screen does. It calls other functions, average, fast, and slow, and then number list display, and then set some text. All pretty similar stuff to what we've seen. Let's take a look at these average, fast, and slow functions, though. Those are going to be the big new things for us with this lesson. Okay, let's take a look at the average function. What does it do? Well, it creates a local variable called total, set to 0. And then it's going to traverse our miles time list from I equals 0 to the length, and going up by 1 every time. And that'll be your typical pattern for traversing a list, going from 0 to the length up by 1. And then each time through, what's it doing? It's setting total gets the value of total plus the mile time at I. So whatever mile time was there. What this list is going to do then is compile all our different miles together, and then at the end it's going to set the average variable equal to the total divided by the list.length. Okay, so essentially we're calculating the average. Pretty common looping pattern for you there. We'll kind of reiterate that more in the later kind of bubbles here. But you loop through the entire list, you accumulate, you add up all the values, and then you can use that to find the total or the average or make different calculations like that. Okay, what else did that update screen function call? What also called two functions called fast and slow. They're essentially the same thing. They're finding the maximum and the minimum. We'll look at one of them. Looks like slow is the first here. It's creating a variable called temp set equal to 0. This is going to be a temporary slowest value. And then what we're going to do is we're going to loop through the mile times. Okay, from I equals 0 to I equals is less than mile times that length. And then each time, each stop along the way, what we're going to do is we're going to take a look and see if mile time at I is greater than temp. And if it is, we'll set temp equal to mile time at I. So each time through, if we find something that is greater than the temp, we'll reset it, and then we'll assign that to our slowest value here. And okay, I had to think about that for a second. Yep, slowest would be the longest time. Brain wasn't working there. Whoops. Fast essentially does the same thing, okay, but it starts off with a temp variable at just whatever's in the beginning spot, kind of using that as a maximum. And then as it goes through, if it finds something that's less than that temp value, it'll reassign temp and then set the fastest variable there. Okay, so that's a few different ways we can utilize loops to go through a list, to traverse a list, and make some calculations for us. All right, so let's see if there's any directions for us here. Yep, we want to modify. It says create a function that adds together the total time of every element in the list. Console log the result, and then call that function in the update screen function. Okay, well, so we'll just do something and console log it so we don't have to mess with this user interface here. Let's head on down to the bottom and do that. We want to make a, I'll make this a little smaller here, new function. And we want it to find the total of all the values. So we'll just call this function total. And we're going to want to loop through our list. Before we do that, we're going to want to make a new variable to kind of hold on to that total. So I'm going to make a variable called total and set that equal to 0. And then what I'm going to do, I want to loop through my list once again. So I have a counter variable starting at 0, and then we want to go through, well, I is less than mile times that length. And notice all my loops have that same stopping spot starting at 0 and continuing while I is less than miles times, is it mile time? Yep, mile times dot length okay, and within the loop, what we want to do is we want to take our total variable and set it equal to total. I can type, I promise. Okay, plus the value in the list at that current index. So that'll just be mile times with square braces at I. Okay, what that's going to do is that's going to add the mile time of the current index to our total variable. And then what we want to do is after that loop is done, I want to console log total. And then it said to call that in our update function. So along with all our other functions being called here, we'll call our total function as well. Let's see if that works here. Reset and run. So I'm just going to put in some times for the mile. So we ran a 1 minute mile somehow, 2 minute mile somehow, a 8 minute mile. Yep, and it looks like as I'm doing those, 1 plus 2 plus 8 is going to give me an 11. It is console logging that total at the bottom. Okay, feel free to play around with this app more if you want to. You can add more to it. If you ever break it, you can use the version history to start over. But I'm going to move on here to a few more examples. All right, on level 3, notice we have something different going on here. Code we have is console log get column, okay, cat name. Now let's take a look at what's going on here. This get column that's colored a little different here. We haven't seen that command before. It's actually colored with this data deal. Okay, what we're going to add here is a way to kind of access, modify, and use values from databases. Okay, and when I run this, looks like I get a list of a bunch of different types of cats. Let's take a look at kind of where that data is at right now. Now, if you notice, there's a new tab up here, tab for the code, tab for the design with our buttons, and also a tab for data. And what code.org comes with is a bunch of different data tables with all kinds of different information stored in it. Stuff as simple as looks like list of cats, information about different cats, to, there's a cool one I just saw, some COVID-19 info per country, which could be kind of interesting to look into. And what I can do is I can import those data sets into my actual app here. I already have the cats one imported for me, and essentially what it is a big table of cat names, min lifespan, max lifespan, weights, temperament, origin, images of them all. Okay, so if you're a big cat fan, there's all kinds of different information. Looks like about 67 different rows of types of cats for us. Okay, so when I go back to my code and I run this, essentially what we're doing is we're getting the column from the cats table and the column named name, and we're printing off all the different types of cats here. Okay, what else can we do this? Look at the code, modify to print a column of data from the data set chosen. In case we could print something else, instead of name, we could print its temperament, I suppose. Why not? Reset and run. And we get a big list of different possible cat temperaments. All right, so that's some different ways we can access that data table. We'll do more data as we move on in the course. Just something to show you here because you will use data a little bit in the next practice lesson. All right, level 4, let's just take a look at another app that utilizes some list and list traversal. Okay, this one here is a random dog picker, where essentially I pick the size I want, and it's going to give me a random dog of that size. Looks like I'm getting different stuff every time. Okay, and how is this working? Well, first off, it's creating 3 different lists, okay, from the dog database that code.org provides. And the idea happening here is we have parallel lists where the first dog name would match up with the first dog height and the first dog image. Okay, so we'll have 3 large lists of dogs. And they also have some empty lists for filtering through things. Let's see what happens here. The one way we can interact with this app is that drop-down change. It's calling the list setup. And then it's doing something called filtering. Basically, it clears out those filtered lists, empties them out again every time. It grabs a size from our drop-down, and then it's going to run through the dog height list from 0 to length. And I suppose we could use any of those 3 lists because they'll be the same size. They're parallel lists. And then it's going to determine if the dog's height is less than 16 and it's small. It's going to add that dog to the filtered lists, both the name and the image. And then, or it's going to check and see if it's a medium dog, okay, or a large dog. So essentially it's going to create the filtered lists based on what we plugged into the drop-down size here. Okay, and then from there it's going to update the screen where it's going to pick a random index and then set the name of the picture to random values from those filtered lists here. Okay, and that's how every time I pick this, it's creating a list of small dogs and then picking a random one to put up there. Okay, a lot going on with this app, kind of complicated. I don't believe there's anything for us to modify here, but this wouldn't be a bad idea. Take some time, explore it, play around with it, break it, reset it. Okay, it's a great example of some transversal in action. Okay, then last thing we have for you for this lesson is there are 2 bubbles with some different notes on transversal patterns, some stuff we talked about. Okay, it's good to have kind of a formal what do we want to say, a formal example of these different types of patterns. That's what these codes are. So take a few minutes, read through these bubbles. Okay, these will be patterns you're going to utilize in the practice lesson. And then once you're done with that, there's a quick question to answer on level 7. And then after that, you are done with this lesson. Cool. We'll start practicing this stuff next time we see you.